question one, I wanted to review the different factorization patterns that you encountered. There's several new ones that we had. We have the sum of two cubes, difference of two cubes, and factoring by grouping. So in 1A, it is a combination of taking out your greatest common factor and the sum of two cubes. So every time you do factoring, your first priority is to look for any greatest common factor that will go into all the terms. Well, if I look at a 16 and a 54, they're both even numbers, so I know I can factor out at least a 2. So I'm going to factor out a 2, and what I'm left with is an 8x cubed plus 27y to the 6th. Okay, just because we factored out a greatest common factor doesn't mean that we're done, so we have to reevaluate the remaining factor that we have. And that stuff that I just highlighted with the pink above it, that is the sum of two perfect cubes. 8 is a perfect cube of 2, x cubed is a perfect cube of x, 27 is a perfect cube of 3, and y to the 6 is the perfect cube of y squared. So the way that we do these, the factorization pattern says if you have the sum of two perfect cubes, a cubed plus b cubed, then it can be factored in to the cube root of the first thing plus the cube root of the second thing times the first thing squared minus the first thing times the second thing plus the second thing squared. And when I say first thing and second thing, I'm referring to A and B. So now I'm going to apply that to our specific example. So we already have the 2 that was factored out. We'll leave it out there. Now we're going to factor the sum of these two cubes. So I want to take the cube root of the first thing, which is the cube root of 8x cubed, which is 2x. Then I want to take the cube root of the second thing, which is 3y squared. Then, in order to get your second part of this, you square the first thing. So my first thing is 2x, so I'm squaring it. That's 2x times 2x, or 4x squared. Then you multiply the first thing times the second thing, and the signs are always opposite in here, so minus 6xy squared. Then you square the last thing, or the second thing, which is 3y squared times 3y squared, or 9y to the 4th. So this is the factorization of 1A. I'm practicing the greatest common factor and followed by the sum of two perfect cubes factorization pattern. Just one more plug on these. When you take the perfect cube of these numbers here, the perfect cube of 27, you're going to have to figure out what number do you multiply times itself. 3 times you get 27. But on the y to the 6, or any power, as long as these are divisible by 3, they will be perfect cubes. Y to the 6th is y squared times y squared times y squared. If it was y to the, as long as a multiple of 3, so it could be y to the 12th, and that would be y to the 4th times y to the 4th times y to the 4th. And what I'm trying to illustrate here is that they are perfect cubes. 4 times 3 is y to the 12th, or if you use your product rule, you add those 4 plus 4 plus 4 and get 12. The same thing as y to the 6th. I can rewrite this as y squared cubed. So there's where the term perfect cube comes into play. So I expand a little bit on the idea of perfect cubes, but we've talked about it before. I just want to try to reemphasize it one more time. So there's your first one.